Cast your mind back. The year is 1977, August 20th to be precise. A Titan IIIe Centaur rocket stands poised. Its precious cargo, Voyager 2. This wasn't just any spacecraft, it was a bold emissary, a tiny piece of humanity, ready to embark on an epic journey, a journey to the outer giants of our solar system and beyond. Voyager 2 wasn't alone in its conception, it had a twin, Voyager 1, launched a couple of weeks later on a faster, shorter path. But Voyager 2 was the pathfinder for the grandest tour. Its mission was ambitious: to visit Jupiter, Saturn, Uranus, and Neptune, to peel back the layers of these mysterious worlds, to send back postcards from the cosmic frontier. Imagine the sheer audacity, the brilliant hope. This was the 1970s, a period of technological marvels. We had walked on the moon. Now our gaze turned further outward. Voyager 2 embodied this spirit, a spirit of relentless curiosity. Why then? Why 1977? It was all about timing, cosmic timing. The outer planets, Jupiter, Saturn, Uranus, Neptune, were aligning, a rare celestial dance. This special arrangement happens only once every 176 years. Imagine that. Once every 176 years. It was an opportunity too good to miss. A cosmic invitation. The universe itself seemed to beckon. We had to answer the call. This grand tour alignment was the key. It meant a single spacecraft could visit all four gas giants, using each planet's gravity to swing to the next, like a cosmic game of billiards, or a perfectly timed slingshot maneuver again and again. This saved enormous amounts of fuel, and crucially, time. Without this alignment, such a mission would be far harder, perhaps even impossible with the technology of the day. So, the pressure was on. The launch window was narrow. Miss it, and humanity would have to wait. Wait for another century and 3/4. Think of the generations that would pass. The scientists at NASA's Jet Propulsion Laboratory knew this. They worked tirelessly. How do you send a small probe across billions of miles? Especially when you're on a budget, cosmically speaking. The answer is ingenious: gravity assist. Think of it like this. A spacecraft flies close to a massive planet. The planet's gravity pulls on the spacecraft. It tugs it, accelerates it, and can change its direction. It's like a cosmic dance. The spacecraft essentially steals a tiny bit of the planet's orbital energy, a free boost of speed. Voyager 2 became a master of this technique. Each planetary encounter was meticulously planned, not just for science, but for the next jump. Jupiter gave it the kick needed to reach Saturn. Saturn, in turn, propelled it towards Uranus, and Uranus flung it towards Neptune. It was a chain reaction of gravitational nudges, each one perfectly calculated, billions of miles from Earth. What a feat of navigation! The precision required is mind-boggling. Imagine trying to hit a moving target from millions of miles away, and that target has to send you to another moving target, even further away. The navigators were like cosmic sharpshooters. Tiny thruster firings made all the difference. Planetary encounters, a quartet of giants revealed. First stop, Jupiter in 1979. Voyager 2, following its twin, gave us breathtaking views. The Great Red Spot, a storm larger than Earth, swirling with unimaginable power. But the moons, Io, a volcanic hellscape, constantly reshaping itself with sulfurous eruptions. Europa, covered in ice, with hints of a subsurface ocean. Could there be life? The question still hangs in the air. Jupiter and its family rewrote our textbooks. Our understanding of planetary systems expanded overnight. Then, on to Saturn, the jewel of the solar system, in 1981. Those rings, we knew they existed. But Voyager 2 showed their true complexity. Thousands of intricate ringlets, braided structures, spokes, shepherded by tiny moons. It was a stunning, dynamic system. Titan, Saturn's largest moon, beckoned, with its thick, orange, nitrogen-rich atmosphere. A primordial Earth, perhaps? More questions, more wonder, more data streamed back. Beyond the sun's embrace, entering interstellar space. After Neptune, what then? Voyager 2's planetary mission was complete. But its journey was far from over. It was now heading outwards, towards the boundary of our solar system, into the vast unknown. The sun's influence, the solar wind, began to dwindle. It was venturing into a new domain, the space between the stars, a truly pioneering path. What is this boundary? We call it the heliosphere. It's a giant bubble, blown by the solar wind, a stream of charged particles from the sun. This bubble shields us. It protects the solar system from harsh interstellar radiation. Voyager 2 became our scout, tasked with finding the edge of this protective cocoon, to measure where our sun's kingdom ends and where the interstellar medium begins. It was pushing the limits of exploration. Voyager 2 first crossed the termination shock. This is where the solar wind slows down dramatically. meeting the pressure of interstellar space. That happened in 2007, then it pressed on towards the heliopause, the true outer edge of the heliosphere. On December 5, 2018, it happened. Voyager 2 punched through. Echoes from the Voyager 2's ongoing interstellar watch. Even now in 2025, Voyager 2 is still talking to us. Think about that. Nearly half a century later, it's billions of miles away. So far that its signals traveling at light speed take many hours, currently over 19 hours one way, to reach the giant antennas of NASA's Deep Space Network. These sensitive ears on Earth listen patiently for the faint whispers from this distant traveler. A conversation across cosmic voids. Its voice is weak, but its message is powerful. What is it learning out there? In the cold, dark expanse between stars, it's measuring the interstellar magnetic field, sampling cosmic rays that originate from distant supernovae, analyzing the density of the interstellar plasma. This is uncharted territory. Voyager 2 is providing us with our first direct taste of the environment our sun moves through. As it journeys around the center of the Milky Way galaxy, this data is invaluable, unique. Of course, it's an aging spacecraft. Its plutonium power source, the RTG, is slowly decaying, providing less energy each year. Engineers on Earth perform miracles, carefully managing its power consumption, shutting down non-essential instruments, to keep its scientific heart beating for as long as possible. A beacon of curiosity, Voyager 2's enduring legacy. Voyager 2 is more than just a collection of instruments. It's an ambassador, a time capsule. It carries the golden record, a gold-plated copper disc, containing sounds and images of Earth. Music, greetings in many languages, pictures of life, a message in a cosmic bottle, flung into the ocean of stars, for any potential extraterrestrial civilization that might find it, millennia from now. What a hopeful, audacious gesture. Its impact on science is immense. It revolutionized planetary science. Our views of Jupiter, Saturn, Uranus, and Neptune were transformed from fuzzy telescopic images to vibrant, detailed worlds, each with its own unique character and mysteries. It inspired countless students to become scientists, engineers, dreamers. It fueled our desire to explore further, to understand our cosmic neighborhood, and our place within it. Voyager 2 stands as a symbol of what humanity can achieve. When we are driven by curiosity, when we work together, when we dare to push the boundaries of knowledge and exploration,